Yeah, welcome everyone. Well, you have heard the title of our presentation, a variety of fast farms and why you'd need one. An alternative title would be how not to get desperate while designing your own fast farm, while new fast farms are emerging every day. Hi, my name is Boris Ryutin. I've been in security research since around 2011, and I've been talking about that. I talked about that yesterday. I made a presentation on reverse engineering, and today we'll be discussing fuzzing. And in recent years, I've shifted from my security audits to designing secure processes, and I'm a trainer as well. Hi, my name is Pasha. I'm a reverse engineer. I look for vulnerabilities and I exploit them. And a couple of years ago, I went into DevOps security. I began to research all kinds of scalable fuzzing solutions. And in my presentation, this presentation actually, we'll be talking about various fast farms and about our own solution that we made public. Yeah, we thought of coming here dressed as peasant farmers and bringing space with us and stuff, but then we realized that we would have to be traveling by public transportation to reach this place. So we decided against this. Now, in terms of our inspiration, is the article that I've been bringing in my presentations for the past 5 years, but it's still very relevant. How to prevent the next heartbleed, and it's not just an article really. It's a major essay. It was published more than 5 years ago. The first version of it was released in 2013, and the latest one came out in April this year. So he says you have to have fuzzing, otherwise you wouldn't be able to find anything exciting like heartbleed. You have to combine different techniques, but fuzzing is an important component of the whole process. But I think you also know the paper that was published by a developer of Carl utility 5 years on OS Fuzz. In his project, he was one of the first who added Fuzz farm to his open source project. So at first, it was continuous fuzzing. Later, when new forks came out, new cluster fuzz varieties came out, and you could have an individual fuzzer for every commit PR. He started doing that, and he published his results. Actually, very few people talk about how they implement fuzzing, although in the previous presentation, the speaker went into a lot of details about his own experience. Continuous or non-continuous fuzzing or interrupted fuzzing. The translator suggested using non-continuous but interrupted or broken fuzzing, but I prefer non-continuous actually. So what do people want from a fuzz farm? Doesn't matter whether you want to fuzz something in a consulting company, or you implement security processes in developing company, or you are a consultant yourself who helps others set up their processes. So what people want is to get a fuzzer, send them to some magical infrastructure. You can also add some corpora to the fuzzer, because no one is going to hit XML all the time. It's best to explain which attributes the file has, and it would be wonderful if this entity would return some results to you, useful results, bug checker or something, so that you can use them somehow. To go back to the 5-year fuzzing results from the Coral utility designer, continuous fuzzing. Like I said, he added that to his utility. It was fuzzed all the time. So the approach when you fuzz a build doesn't matter whether it's pre-release or a release build. Of course, you can keep the fuzzer going on continuously. But what about non-continuous fuzzing? It's a frequently asked question, actually. People tend to ask all the time, how much time do I dedicate to fuzzing? Do I use coverage as a benchmark or something, or you can start fuzzing for every commit? The developers say that when you add fuzzing to every commit, in the very beginning, the fuzzing test code would crash all the time. Your code would be proven to be not secure, but it gets better with time, and then with time, the fuzzers find no more bugs. Coral is developed via GitHub, and GitHub Action is used to launch fuzzers, and GitHub Action has a limitation of 6 hours. So the very first iterations when he tested fuzzing per every commit, they would be crashing all the time, but later the code became more secure and they wouldn't be crashing that often. Now, as to the process, I think it's clear now what to do with Fuzz tests. Where do you get them from? Because people are asking this question. Do we need to ask developers to write them, or do we need to hire security experts to develop them for us? And actually, there are solutions on the market. The first one is CI Fuzz. You can find it at GitHub and use it. We will talk about it in detail at subsequent slides, but CFuzz will allows you to generate the simplest Fuzz tests out of the box. Then Fuzz Data Provider. Probably some of you are already familiar with this solution. This is C++ header library that enables you to unify the values of the input variables and to write the simplest test. The Fuzz cover is an open source library. You can review it. It's just that in the past 2 years it was sitting on the shelf, but under the trunk it has Fuzz Data Provider. CFuzz, actually CFuzz, also uses Fuzz Data Provider. And for tech, I think there also is somewhere here around at the conference, but these people also have an idea how to generate Fuzz tests automatically. In 2023, we saw new trends emerging. When we prepared this project with Fuzz Farms, we were also thinking, how can we scale out Fuzz tests? How can we write them faster? Microsoft in 2017 published a cool paper exactly on this topic, how to use machine learning to generate fuzzing inputs. They continued their research. We looked into it. We would like to do something similar, but then we realized that either we would have to become not an information security developer, but to become an ML expert. But okay, so we started looking around. We didn't want that. We started looking around, and we found that there are options now like ChatGPT or other GPT-like systems that help you write Fuzz tests. What are our other expectations of a Fuzz farm? The crash that was identified by a fuzzing engine, it should be reproducible. I think that you had cases when L++ fuzzes code, it finds hangs and crashes, and in the hangs, you can, among them, you can find a real crash. And deduplication, of course. Out of those thousands and thousands of crashes, are they all different crashes? It's something that we need to know, or it's just that everything is concentrated in one place. You just need to write one exploit for the whole function. And coverage, of course. Your fuzzing tests, you need to understand what's the percentage of your code, of your project that you research or protect, what percentage of it is covered. So, in terms of a quick summary to what has been said, what are the main features of a Fuzz farm? What are the main advantages of a fuzzing farm? Well, a fuzzing farm should launch fuzzers. We should have a system that would schedule fuzzers initiation. It should be able to plan. The planning should be smart. Better fuzzers will get more resources and time for fuzzing. The poorer fuzzers they should be taken offline. Then Boris also mentioned the duplication of crashes. I can only confirm that. Fuzzer can generate lots of crashes. They would be repeatable, and the farm should have good duplication algorithms to return just unique crashes and to be able to reproduce them. For the researcher not to do all of this with his or her own hands. Another important feature is statistics collection. We need the data to understand how well a fuzzer operates, and of course it should integrate with CI/CD and with backtracking systems, regression testing. This is when we need to check whether the bugs that we found were patched. So you start the code of the new product at the farm, and in terms of inputs, it receives all the earlier crashes. Then we will know that all the vulnerabilities were actually patched. And vulnerability assessment, a farm can assess a vulnerability and rate it. Is it a critical vulnerability or a non-critical one? I will add a couple of words here. We know what our expectations are. This is the desired state of affairs, but we've been asking around. We talked to colleagues who are already working with a Fuzz farm or who are planning to have one. They are looking for something like this. They want a fuzzing farm to write test itself and record crashes and collect statistics and patch the code too. So let's talk about the fuzzing farms proper. We'll start with cluster fuzz. A major product that was released in 2019. It was developed before that, but the code was opened in 2019. That's when Google published the source code. The Fuzz farm is deployed in Google Cloud. It has a good web interface. Google develops its own fuzzing engines on Fuzz FL. In the documentation, Google states that they have their own cluster for 30,000 virtual machines, and as of February 2023, they found about 27,000 bugs in their own products and another 28,000 bugs in open source projects. In terms of features, Cluster Fuzz is highly scalable. It supports all kinds of OSs. It integrates with CI/CD and bug tracking. It collects rich statistics on the fuzzer and on the crashes. It supports all the best-known engines. Syscaller, this deserves a special mention. Syscaller itself is a mini fuzzing farm. It is used to search for vulnerabilities in the kernel of an OS, and ClusterFuzz managed to integrate that. They also support all kinds of languages. In terms of engines and languages, fuzzing farms are developing all the time, so we may have added something that we have not recorded, that we missed actually. How do you set a job in Cluster Fuzz? In accordance with Google's documentation, you need to run everything in the cloud. You start the web interface and you enter a new job. The name of the job, then the templates. They are predefined variables of the environment which contain configurations for the sanitizer and the fuzzer. And then you upload the file, the archive where the fuzzer is stored. Once you are done, you go to the bots folder. Bots are worker VMs that run fuzzing jobs. You see, by default, 3 VMs are set up, and each one carries its own payload, carries its own fuzzing job. And then after a while, in my experience, it's about 3 hours, you start receiving first information about the crashes. This is the panel with the crashes. This is a demo of Fuzz. It generates lots of crashes, I mean duplicates. And the cluster Fuzz shows you just this list. So it's got an excellent deduplication algorithm for crashes. You can tell that it can also reproduce crashes. And it tells you whether it's security related or not. This is a crash information. You can see the stack trace, the input that caused the failure of the program, and it offers you all kinds of information. I also wanted to mention another project known as OSS Fuzz. This is production version of Cluster Fuzz that's deployed on their own facilities. It's used to fuzz open source software. I don't want to go discussing this schematic in details, but you have to understand that anyone who has a critical open source project can integrate into OSS Fuzz free of charge and launch your own fuzzers there. Actually, if your fuzz integrates well with OSS Fuzz, or your project integrates well with OSS Fuzz, you can get rewarded for it. OSS Fuzz has a, or rather Cluster Fuzz, has a younger brother called Cluster Fuzz Lite. It has the same engine, but it has a different task. It integrates into the pipeline. You are building a product, you are testing it, and then you launch Cluster Fuzz Lite, and you fuzz test your pipeline for a couple of hours, maybe. In terms of its features, Cluster Fuzz Lite finds vulnerabilities quite fast. They are found before they go into the release code, because after every master push we do a Cluster Fuzz Lite. Now, engines, languages listed on the slides, and they also offer documentation in terms of how to integrate with various CI/CD workflows. To play with it, I found this project at GitHub. It's called Cluster Fuzz Lite Example. It shows you integration with GitHub. Well, it has integration with GitHub Actions. You add a couple of comments and you do a push master. Over here, you see the pipeline, the tasks. The images were downloaded, and when launched, the Cluster Fuzz Lite found a crash. It failed, so the developer needs to find this failure and fix it. At the lower part of the slide, you'll see the code that was generated by the Cluster Fuzz Lite and detailed information about the identified crash. Cluster Fuzz Lite can also produce coverage reports. It shows you which lines of code were covered during the fuzzing test. I have to say that generating a coverage report, it's a feature of FuzzLV. Cluster Fuzz Lite uses that feature. Next is One Fuzz project. Microsoft showcased its own fuzzing solution. It's also an open source solution, and it was used to fuzz Microsoft components, Windows components, and Microsoft Edge internals fuzzing. It runs in Microsoft Azure, but I couldn't find a web interface. I only found a CLI and an SDK. Out of the features, I should mention that it's highly scalable. It supports Windows and Linux. It has CI/CD integration. Another interesting feature is live crash debugging. This is when a vulnerability is found, and you can go to the vulnerable code and launch the debugger that led to the crash, and then you will be able to research the vulnerability in detail. It also has notifications. It can send GitHub issues on found crashes, and it sends messages to Microsoft Teams. In terms of engine supported, libfuzz, AFI, Radamsa languages, I found examples for C and C++, Rust and Go. But if you go into the original papers, you can also add your own engines, and there is the Fuzz project, which is developed by one of the employees of Microsoft. So if you've got any .NET projects, then I suggest that you consider using Fuzz. Now let's talk about CLI. The first team creates the pull object. It tells you which fuzzers we are going to run, Linux-based or Windows-based. Then we must create a group of worker virtual machines that will run fuzzers. Here we create a pool. Initial size is 3. It can be scaled to 10 VMs, and the virtual machines are quite small, 1 gigabyte of memory and 1 core each. Then here is a command that we use to launch the fuzzer. And while waiting for crashes, we are enjoying the Fuzz status top view. It shows you all the polls, all the tasks, all the jobs, all everything. Basically, all the messages are here. Even if you don't understand anything, it's a nice picture to look at. And finally, we check for crash reports. We use this command, and we see that there are new files available now. And we use one other, not very complicated command to retrieve the content of the report. It shows you the input, cool stack, etc., but it's not the same as having a proper interface, and it's not very easy to read. Now, switching from open source projects to commercial projects. A good fuzzing farm was released by Code Intelligence. The main concept is fuzzing as easy as unit testing. A fuzzing farm is for developers that want to switch from unit testing to fuzzing and who are learning to write their own fuzzers. It's on-prem, so you pay for the solution, you receive the images and deploy them on-premise, but they also offer a free playground, and they're also in the process of developing their own engine for Java fuzzing. They have a good interface and the CLI. The features are listed on the slides. They've got web API fuzzing, so it's not just fuzzing of a function, but you can fuzz a whole service like REST API or Protocol. You can also get real-time fuzzer run metrics. They provide vulnerability scoring, and they integrate with DE. I'll show it to you later. Languages supported C and C++ and Java. They're the ones listed in the documentation, but it looks like you can fuzz JavaScript and Go. And probably I should also mention that Code Intelligence in general, they studied and they developed as a fuzzing farm with Java. They did their own solution, and Google uses their version. CS was released recently, and this is specifically for JavaScript. I enjoyed the interactive training. It shows you how to write your own fuzzer and how to upload that onto a farm. This fuzzing farm has two modes of operation. Using CI Fuzz, you can build a fuzzer and initiate it and collect the metrics, and then the results. So the outputs will be uploaded to the farm, and they even suggest that you create a new project. This is how information about the vulnerability is represented. You can see here the score, detailed information. All of this can be presented in greater details, just like what other fuzzing farms are doing. And it also collects a coverage report. A remote run my fast test is the second mode of operation. You build a fuzzer, you upload it to the fuzzing farm. You have 30 minutes to fuzz free of charge. And here are the real-time metrics. And integration with DE. So you don't even need to use CLI. You press a couple of buttons, all of this is built automatically and uploaded onto the farm without your involvement. Okay, Boris? Yeah, let's turn to the GitLab solution. I'm sure that many of you are already using it. GitLab bought Fuzzed startup some time ago, and they position it as an additional feature in the ultimate subscription as a security feature. They also have the API. They've got their own fuzzers that they acquire together with Fuzzed, but JavaScript fuzzer compared to Jazzer, theirs is not the best. But the main feature here is because it's a repository, it's a version control system, so there is a smooth integration with it. Out of the box. Fuzz Manager it's a set of scripts on Python, and they've got some Django interface. It's by Mozilla. If you are improving your fuzzing skills, probably you will come across the fuzzing book, and most likely it will lead you to using the fuzzer. It's on Python. It's runs in Amazon Cloud. Hopper is a new fuzzing farm. It's quite straightforward. It's Go-based. I think they came out this winter. It's very simple, simplistic even. The developer offers its own mutanter. But it's nice observing the evolution of this hopper and Go, and they've got some interesting features. Bugbane is a Russian solution they released last year compared to other products. Bugbane generates reports. I don't know if you know, but to be certified, you have to demonstrate that you have fuzzing testing. This is a rule that exists not just in Russia, but say in the United States too, and it integrates with Defect Dojo. Yahoo fuzzing. It turns out that Yahoo also has a Kubernetes-based fuzzing farm. It scales, it's written on Go, but it was archived about 8 or 9 years ago, and it became public sometime later. The only commit it has is the Google released ClusterFuzz, and it says just go and use ClusterFuzz. We are desperate. Coinbase. It turns out that Coinbase lives not just with bitcoins, but they have their own fuzzing farm. It's also Kubernetes based. It also runs on Amazon, but it was also archived about 8 years ago. But looking closely, the developers of this big fuzzing farm, they started their own startup, Fuzz. I think they opened in 2022, and they even won a small round. They had their own fast test generators out of the box. Another feature is they have their own virtual machines. You can set up master boards and connect not just boards, but individual virtual machines to fuzz your code. So it's quite simple. It also has integration with Intelligence ID. However, this site is no longer active. So I suspect that was also archived. I don't know the reasons, but you can tell that the developers of FuzzBuzz, they still contribute something to the private repository. So maybe in the future we'll see BuzzFuzz 2.0. The reasons to think about your own fuzzing farm. First of all, vendor lock. Certain clouds do not allow you to launch certain OSs like Mac OS. It's very difficult to do it. Google, in most cases, probably told you that they want to have jailbreaked iPhones in order to test them. Another reason is costs. Of course, we all try to save, and maybe one cloud costs that much, and another cloud costs another much, and maybe you can ask for a discount from the first cloud, but you have to prove that you need to migrate painlessly. And then NDA. Very few would like to share the source code for fuzz testing. It doesn't matter whether you are fuzzing your own project or some third-party project. And of course, risks. You shouldn't forget about that. Amazon can just throw you out together with your fuzzing farm and lock access to its capacities. That's why we decided to develop our own fuzzing farm, Bounty farm. We started with Python scripts. We wanted to match them somehow. And all of this was, every host had its own fuzzing farm. Then we tried to use virtual machines. Then we switched to smarter virtual machine control solutions, XXI things. There were several iterations and solutions. And then eventually we realized that, of course, we'd like to emulate hardware, but let's start with a minimal solution, a minimal viable product, simplest interface for the fuzz containers. Unfortunately, at the same time, Kubernetes came on stage, and as a result, our fuzzing farm is Kubernetes-based. It allows us to be deployed in any cloud infrastructure supporting Kubernetes. Secondly, what we wanted to achieve actually is we didn't want source code integration to be mandatory. Of course, all security people will tell you that you can always reverse engineer the source code, but it still gives you an opportunity to do fuzzing without access to the source code. And we also wanted our fuzzing farm to integrate with any custom solution. That's why we followed 3 tracks: a console utility, a lovely web interface, and some API. We decided that we needed all 3 in case if your utility is Rust-based and we want it on Python, we can use an API. So the whole farm also supports all DevOps processing. We also wanted to integrate with API to be able to integrate with bug trackers. So, what are the features that distinguish our product? First, we have smart scheduling. As Pasha has already explained, for instance, we'll launch 3 fuzzing tests at the same time, but we understand that one of these fuzzing tests is no longer finding any crashes or paths, so why waste resources on this fuzzer? So we lower and lowered the weight of this fuzzer, and then we stop it. But the remaining fuzzers, if they still find new paths and new crashes, then they get all these spare resources. This is a very economical approach to resources. But Fuzz, by the way, I think they are the first to introduce the notion of a fuzz minute, because people talked about fuzzing years, fuzzing months, fuzzing hours. They started talking about fuzzing minutes. Crash duplication reproduction, of course we have that. So we're going to show you the lovely screenshots. We have our own deduplication algorithm. Probably it's not as powerful as you find in academic papers, but once we found more than 1,000 crashes, the fuzzing LG L++ found that 30 of these 1,000 are unique crashes, and after duplication, we found 30 unique crashes, and it's easier to deal with 30 than with 1,000. And reproduction, of course, we wanted that. Integration with various fuzzing engines. We support 4 languages and several more coming, like Jazz.js. Custom images. Since they are containers, we need sometimes a special flavor of Ubuntu, like Astra Linux or something in Docker containers. This, of course, we have statistics. Oh, and by the way, in those containers, you can embed additional dependencies, because sometimes when you launch a fuzz, you need something special, right? CI/CD integration goes without saying. Using Clio utility or an API. Bug tracking, we integrate with UTrack and Jira. Bug trackers, they are the trackers that we used in different periods of our practice, and web interface and CLI utility, like we were saying. Then we realized that it was too big for us, and in order to test a demo, no one will allow us to use Kubernetes right away. So we started thinking about something like Cluster Bus Lite, and in terms of painless migration, we found a small Kubernetes. K3CS and others, but we decided to use Kandi. We have an active kind fuzzing farm, and this is Bounty Fuzz. This is how it looks like. We also have a system of projects implemented, because we fuzzed everything in the different periods of time. We felt the need to do fuzzing tests of various projects, and we wanted to keep them separate. We wanted every project to have its dedicated capacity. We have a Kubernetes cluster, but we want to be able to allocate memory and CPU resources to different projects. Here we've got 3 projects. One of them bears the name of our lead designer. 4 different fuzzers are running. One of them is already stopped because its weight went down, and it sped its resources to other fuzzers. Heartbleed is here. Of course, we tested on Heartbleed, LeadJPEG. What else is there? How do you create a new fuzzer? The process is straightforward. You select the language, depending on the language and the engine too. Maybe you want to use a fork, like libfuzzer. Google started developing its own rather than this one. The images Ubuntu's 17 to 22. Then, in the specific project, you can select how much CPU and memory will be dedicated to this project. Memory, of course, that's very important. We want it to be as powerful as possible. And operating memory, why RAM? Because some fuzzers require only 100, 200 megabyte. But if it's libSQL Lite utility fuzzer, then it will require at least 4 gigabytes. It will find some crashes if it only has 2 gigabytes, but then your own machine will crash because it will not have enough memory. Everything else is quite standard. An upload fuzzer button. What else is there? Different options and seeds. For instance, for Heartbleed demo, for it not to run for 3 hours, we would upload intermediate seeds that help us demonstrate heartbeat within minutes, not hours. This is a test fuzzer. You see we've got deduplication, the type of crash, the type of bug. It shows you how many familiar crashes are detected. And we also implemented the simplest availability management and security research elements. Security research, you can download the crashes and use them to write an exploit, or archives. When you see that the archive, or rather this crash, is repeated, or deduplication perhaps is not working very well, then our crashes will be sent to an archive, and then all the duplicates of this crash will be stored in that crash archive. You will not see it, and you will not get distracted by it. And of course, we've got these beautiful graphs that you can demonstrate to the managers, to the leads, the executions per second, the number of results total, and different crashes. We found 4 graphs, or we selected 4 graphs for this presentation. And for the solution, to keep it simple, we believe that these 4 parameters are enough. And your next question will be whether it's open source. Yes, it's open source. Here's the code. We wanted to publish it 1 hour before this presentation, but then we thought that maybe it would not be very fair. Other people will be sitting here and listening to other presentations, but other colleagues will be able to start playing with it right now. So we are going to open it on Monday. We've got documentation for the user manuals. It's fine. You can live through it, but deployment docs, it's a big headache. I'm sorry about that. Another thing that we couldn't see in every farm, but we think it's still quite useful, crash differ. For you to understand that the crashes are the same, they're not the same, you need to at least get information from hexes. And then, that's what we plan to do in the future. We also want to improve our coverage. We already have coverage that's shown as a table. You saw the graphs, but we also have extensive statistics that displays coverage. But we liked very much the Fuzz introspecting. We're thinking about integrating it. More engines, like I said, we already have some embedded and more are coming. Notification service. Today notification is quite poor. We want to make it better. We have people who love Rust, so they want to rewrite the code in Rust. I wanted to tell you that inside we've got agents, and every agent consumes up to 200 megabytes of RAM. But with Rust, this can be reduced several folds, so the capacity can be spared for other phases. So there are ways towards improvement. And a bonus, we've got 2 minutes left. At one point, we realized that we are focused on binary phases, and our fuzzing farms are open an API. We've got an API. We thought maybe we can use something for API fuzzing. So you may think at this point about Burp. Burp is a commercial solution, but we wanted something similar to integrate with our solution and to ensure non-continuous fuzzing. Why non-continuous? Because one of the fuzzers shown here can scan over 10 minutes. So the idea of continuous fuzzing is that it's continuous, but here it just stops, it has an end. So we considered 3 API fuzzers. Cats is from a researcher, and Dava, we liked it very much. The other one is by Microsoft. We didn't like it much, to tell you the truth. And Open API in Rust, unlike the first 2 fuzzers, it was continuous. It was a continuous API fuzzer. Cats actually helped us find bugs in our own solution. And so we realized that we liked some bits and pieces of all these three products, so we implemented it in one fuzzing engine. So in addition to fuzzing farm, we are also going to present Shelob, our fuzzing engine. It will be discussed in the next presentation. The project involved many people. We wanted to thank all of them, and now we are ready to answer your questions. And here is the link to our Telegram channel on fuzzing. So do follow us and like our posts. Thank you.
Если предвещаю вопрос, да.
Hello, and thank you for the presentation. Your API fuzzer. Is it gray box, black box? Is there introspection into what you fuzz? No, it's the simplest one. Open API JSON. And we start processing, look at the outputs, and then we end up with a solution that can be used in an attack. How do you know that you succeeded? The wrong answer. So it's a black box. Basically, you can not the answer that we expected to get. You see, so basically it's a black box. Yes. Whether we would like to fuzz devices, yes, of course, we would love to do it. And if you look at other cases of fuzzing farm, you will see that there is some controlling entity to which agents are connected, or one of the agents become the central server to which all others are connected. So we already have an idea how we can use our agents on the devices. We understand how to do it, but it's quite difficult, so probably will not be able to do it anytime soon. Thank you for the presentation. What is the niche of your fuzzing farm, given the zoo of other options? Well, it will be difficult for us to occupy a significant niche once cluster fuzz light is out. But, well, cluster fuzz light you can launch on-prem, but others depend on Azure or something else, so they're kind of property-based. But for small, our product works fine for small researchers and small development teams. Bigger companies, of course, we would be very happy if big corporations would use us too, but for them probably it would make better sense to go ahead with bigger solutions. Again, if the risks are appropriate for those products. Other fuzzing platforms. So you are one of the few that can be installed on premise. Yes. Anyway, if you have Kubernetes, you can use our product. Who else is that? Is Yahoo that's archived? Winbase that's archived. I think something similar was mentioned in the previous presentation. Bugbane doesn't do it. They use their own containers. Cluster fuzz light. What about? It's not going to work like this. No. It needs clouds. Cluster fuzz light integrates into the pipeline. You build your project, you build the fuzzers, and the fuzzers are launched in the pipeline, not somewhere outside. So, and this is non-continuous fuzzing. Yeah, you can't have it in the continuous mode. Our solution can be continuous. Cluster fuzz light is non-continuous. So it's built into CI, right? Oh, okay, got it. It looks like we've exhausted. Oh, there is another question at the back of the room. You mentioned that in other countries and in our country too, the regulator requires the fuzzing test outputs. So maybe you have cases when your product would be used for these purposes, for certification purposes. Well, like I said, Bugbane has this pretty feature. When we saw it, we decided to integrate it too. Our solution is simpler. We can download logs, but it's not. Yeah, well, to answer your question, yes, it's possible, but it's not very convenient. It's not the easiest to use feature. Thank you. We would be happy to answer your questions offline, and thank you very much for coming here. Let's give the floor to our next speaker.